All right, so I think I'm recording. Let's take a look at some of these vertical asymptotes and holes problems. Where's, all right. I think this is the right worksheet. Yeah, it'll provide examples even if it's not. All right, so we want to find the domain, and then if anything is excluded from the domain, it'll appear in the graph as either a hole or a vertical asymptote. So the first thing that we want to do is factor the denominator. Now I'm going to go ahead and factor the numerator as well right now, but I'm not going to reduce this fraction until after I have written the domain. Alright, so my domain excludes -4 and +5. -4 is to the left of +5. Those are the only two solutions to the equation x squared minus x minus 20 equals 0. These are the only two values that cause division by 0. We don't have to worry about square roots, or even roots when we're having rational functions, because both the numerator and denominator are polynomials, and polynomials don't have any radicals. So I won't have any inequalities. This is all just about factoring the denominator. So my domain is a set of all real numbers excluding -4 because it would cause division by 0, and also excluding +5 because it would cause division by 0. Now, since these two values were excluded from the domain, as far as the graph, they're going to appear in the graph either as a hole or as a vertical asymptote. We can see that these common factors divide to 1, and that this reduced expression, now it only reduces provided that 5 is not in the domain. Otherwise you'd have 0 divided by 0, and 0 divided by 0 is not equal to 1. So the -4, the factor that remains in the denominator, appears as a vertical asymptote. Now you always want to give the equation and never just the number, because it represents infinitely many points. It represents a line. So I always write it's the line x equals -4. That emphasizes that it's just not an x coordinate of a point, but that it is a vertical line. All right, now the hole in the graph, we want to give the location of that hole, which means we want to provide an x coordinate and a y coordinate. The x coordinate comes from the value that we excluded from the domain. It was coming from the factor that canceled. And now I plug in that 5 into the reduced. If I plug it back into the original function, I'm going to get 0 divided by 0, which is undefined. But in this reduced form, I get, 10 over 9? 5 plus 5 is 10. 5 plus 4 is 9. And I'm just going to leave it as an improper fraction. So those are the two values that they wanted. Now to verify that we have the correct answer, or at least the vertical asymptotes, let's go to that Desmos graphing calculator, and let's plug in the value. So I'll need I'll need parentheses around my numerator. Now, when I provide you a graph, let's at x equals -5, no, I'm sorry, at x equals -4, we have a vertical asymptote. So I'll put that in the graph as a dashed line, and you can see that the graph never touches. It gets closer and closer and closer, but it never touches that vertical asymptote. As you trace out the graph, as you're coming towards this vertical asymptote, since it can't cross it, it'll either turn and go up or turn and go down. It can't just stop out of nowhere. So that's the idea. Sometimes they'll both go up together or both go down, or they'll be in opposite directions. But as you approach a vertical asymptote, your graph is always going to be heading towards either positive or negative infinity. So, oops. Now, these graphs don't have enough detail to illustrate the whole at x equals 5 and 1 1/9. So at x equal, well, I don't even have it on here. Let's go back and maybe. I'll duplicate and then convert that to a table. And when at -4, you see that it's undefined, that it's not in the domain because it's not related to any y value. And then at +5, the same thing. Now, I would like to know the y coordinate of the whole. So if I come in and graph the reduced function, it doesn't have a hole at that point when it's reduced, because we've canceled the factor that caused the hole. So x plus 5 over x plus 4 is going to look, as far as this graph is concerned, identical. You can't, if I toggle this on and off, you can't see the difference. See, it's red here and then it turns to orange because it's the same graph. Well, it's almost the same graph. This graph does not have a hole in it. So if I go, and where this was undefined at 5, if I come down here in my table and key in a 5, the 1.1111, well, that's 10 over 9. All right, so I hope that helps, and I'll talk. Sorry for this being long, but when you do the Desmos graphing calculator, it takes a little bit more time. Talk to you later.